Okay, hi everyone, welcome back to this video series on Cisco ASA firewalls. Image recovering using ROMMON. The security appliance provides a way to recover the system image in case the file is lost or gets corrupted and the security appliance ends up in ROMMON mode. If the security appliance is actively running an image file, you can upload a new image in Flash by using the guidelines described previously in the software installation section. However, if an image file is not present and the security appliance is reloaded, ROMMON mode can be invoked to upload an image using the TFTP protocol. You must complete this process through the CLI before an image can be uploaded. Verify that the TFTP server hosts the file in the root directory and that network connectivity exists between the security appliance and the TFTP server. Assign an IP address to the security appliance by using the address command and configure a TFTP server by using the server command. You can map the configured IP address to an interface by using the interface command followed by the physical interface name. The file name can be used to set the name of the system image. For example, example 339 assigns an IP address of 192.168.10.1 to the gigabit Ethernet 0/1 interface. The TFTP server is 192.168.10.250 and the name of the system image file is ASA821K8.bin. To verify whether the attributes are properly configured, use the set command as shown in example 340. Start the FTP process by issuing the TFTP DNLD command. Password recovery process. The password recovery process on a security appliance is used when the system password is either logged out due to configured authentication parameters or lost. This process for Cisco ASA is similar to the password recovery process for an iOS router, which uses ROMMON mode to recover. You should schedule a maintenance window in which to recover the system passwords because this process will require you to reboot the security appliance. You use the following steps for password recovery. Step 1, establish a console connection. This process requires you have physical access to the security appliance. For security reasons, this is to ensure that remote or unauthorized users cannot reset passwords. Consequently, a console connection to the security appliance is required. Step 3, reload the security appliance. You start the password recovery process by turning the security appliance off and then turning it back on. This is necessary when you do not have the password to reboot the appliance from the CLI. Step 3, break into ROMMON. When the security appliance starts to reboot, the startup messages are displayed on the console. Press the escape key after use break or escape to interrupt boot is shown. This takes you into ROMMON mode as follows. You can see here, step 4, set the ROMMON configuration register. ROMMON mode includes the config command, which sets the configuration register responsible for changing the security appliance boot behavior. It can be used to specify how an appliance should boot, ROMMON, netboot, and flash boot, or if it should ignore the default configuration during boot up. When the config command is entered, the security appliance displays the current configuration register value and prompts the user for several options. Record the current configuration register value and press Y to enter interactive mode. The security appliance prompts the user for new values to be assigned to the configuration register. Select all the default values until the system prompts the user to disable system configuration. Enter Y as shown in the following configuration. Step 5. Boot up the security appliance. After setting up the configuration register to ignore the configuration file, boot the security appliance by using the boot command. ROMMON 1 boot launch bootloader boot configuration file contains one entry. Searching for images, loading ASA 821 ak.bin booting. Step 6. Access privilege mode. The security appliance loads the default configuration, which does not enable password to access privilege mode. After the security appliance shows the default Cisco ASA prompt, type the enable command to gain privileged access mode. So you can see here Cisco ASA enable password C or Cisco ASA hash. Step 7. Loads the saved configuration. After you have privileged mode access to the security appliance CLI, load the saved configuration from NVRAM. You do so by using the copy command, which copies the startup config file to the running config as follows. Cisco ASA copy startup config running config. Step 8. Reset the passwords. After loading the saved configuration, change the login, enable and user passwords. The login password is used to get user mode access, and the enable password is used to gain privileged mode access. In the following example, log in and enable passwords are changed to C1$C0123. Step 9. Restore the original configuration register value. To ensure the security appliance does not ignore the saved configuration in the next reboot, you must change the configuration value to reflect this. Restore the original configuration value of 0x1 by using the config register configuration mode command. Chicago config hash config register 0x1. Step 10. Save the current configuration into NVRAM. Make sure that the newly specified passwords are stored in the saved NVRAM configuration. You do so by using the copy command to copy the running config file in NVRAM as the startup config as follows. Disabling the password recovery process. Cisco ASA can disable the password recovery process discussed in the previous section to enhance device security. This ensures that even if an authorized user gets access to the console port, that user should not be able to compromise the device or its configuration settings. Use the no service password recovery command to disable password recovery from configuration mode as shown in example 341. The security appliance displays a warning message saying that the only way to do password recovery is by erasing all files in Flash and then downloading a new image and a configuration file from an external server such as TFTP. With this option, access to ROMMON mode is disabled to protect the system from unauthorized users. You can disable, so example 341, disabling the password recovery process. So you can see here, You can also disable the password recovery process by going through the initial setup as demonstrated in example 342. The security appliance prompts users to reconfirm whether they really want to disable the password recovery process after displaying a warning that specifies the consequences of this option. If you have forgotten the security appliance password and the password recovery process is disabled, the only way to recover out of this state is to erase all system files, including the software image and the configuration file. Make sure that the configuration and system image files are stored in an external server with IP connectivity to the security appliance. Use the following procedure to recover system passwords when password recovery is disabled. Step 1. Establish a console connection. This process requires you to have physical access to the security appliance for security reasons. This is to ensure that remote or unauthorized users cannot reset passwords. Consequently, a console connection to the security appliance is required. Step 2. Reload the security appliance. Step 3. Break into ROMMON. Files will be erased from flash if access to ROMMON is made. The following example illustrates this process, as you can see here. Step 5. Erase system files from flash, as you can see here. Sorry, that's step 4 and step 5, upload a system image, you can see here. And step 6, upload a configuration file. And step 7, reset the password. Step 8, save the current configuration into NVRAM. System monitoring. The security appliance generates system and debug messages whenever an event occurs. The system messages can be logged to the local buffer or an external server, depending on an organization's security policies. This section discusses how to enable event logging and simple network management protocol SNMP polling, which can be used to check the security appliance status. System logging. System logging is the process by which the Cisco ASA generates an event for any significant occurrence that affects the system, such as network problems, error conditions, and threshold breaches. These messages can either be stored locally on the system buffer or be transmitted to external servers. You can use these logs for event correlations to detect network anomalies, or you can use them for monitoring and troubleshooting purposes. The security appliance assigns a message ID to each event it generates. As of version 8.2, the message ID ranges from 101001 to 741006 and contain a brief description of the event. The security appliance also associates each message ID to a severity level ranging from 0 to 7. The lower the security level number is, the more critical the message is. Table 3.7 lists the security levels along with the associated keywords and a brief description. So I'll just go through these quickly. Security level keyword, level description. 0 emergencies used to indicate that the system is unusable. 1 alerts. Message used to specify that an immediate action is needed, such as when a power failure on the standby failover appliance has occurred. 2 critical. Message used to identify a critical condition, such as spoofed attacks. 3 errors. Event used for error messages such as memory allocation failures. 4 warning. Event used to inform about the warning messages such as exceeding certain thresholds. 5 notifications. Messages used to identify a normal but significant condition such as when a user logs in. 6 informational. Event used to classify informational changes such as the creation of IKE Security Association 7 debugging, used to indicate low-level debugging messages such as the acknowledgement of VPN hello messages. Each security level not only displays the events for that level, but also shows the messages from the lower severity levels. For example, if logging is enabled for debugging level 7, the security appliance also logs levels 0 through 6 events. Enable logging. To enable logging of system events through ASDM, go to Configuration, Device Management Logging, Logging Setup, and select the Enable Logging option. This option enables the security appliance to send logs to all the terminals and devices set up to receive the syslog messages. The security appliance does not send debug messages as logs, such as debug ICMP trace to a syslog server, unless you explicitly turn it on using the send debug messages as syslog option. For UDP-based syslogs, the security appliance allows logging of messages in the Cisco EMBLEM format. Many Cisco devices, including the Cisco iOS routers and Cisco Works Management Server, use this format for syslogging. Figure 321 illustrates that syslogging is globally enabled, with debugs being sent as syslogs to an external server to the EMBLEM format. So you can see here in figure 321, enabling syslog via ASDM. Example 343 shows the equivalent configuration in the CLI format. After the logging is enabled, ensure that the messages are time-stamped before they are sent. This is extremely important because in the case of a security incident, you want to use the logs generated by the security appliance to backtrace. Navigate to Configuration, Device Management, Logging, Syslog Setup, and select the Include Timestamp in Syslog option. If you prefer to use the CLI, use the logging timestamp command as shown in example 344. Defining event list. The security appliance robust operating system enables you to define and choose the events and messages to be sent to specific different syslog stores. For example, you can choose to send all the VPN related log messages to the local buffer, whereas all other events can be sent to an external syslog server. You do so by defining and logging list under Configuration, Device Management, Logging, Event Lists. Add ASDM prompts you to specify an event list name, which can be used to specify the level of messages the security appliance should be logging. You can add events to this list based on either the event class or message ID. In the event class option, you can classify messages using the predefined event classes to log specific processes and then assign appropriate severity to them. These classes include AUTH, identifies user authentication messages; Bridge classifies transparent firewall events; CA logs PKI certificate authority messages; Citrix classifies Citrix clients messages in SSL VPN config; logs the command interface specific events; CSD classifies secure desktop messages; DAP logs dynamic access policy messages; EAP identifies EAP messages in NAC implementations; EAP OUDP logs EAP OUDP messages in NAC implementations; EIGRP classifies EIGRP routing events; Email logs web VPN, email proxy messages. HA logs failover events. IDS classifies the intrusion detection system events. IP identifies IP stack messages. IPAA identifies IP address assignment messages. NAC logs NAC messages in NAC implementations. NAC policy logs NAC policy messages in NAC. NAC settings classifies NAC setting messages. NP logs network processor events. OSFP classifies OSPF routing events. RIP logs routing information messages. RM identifies resource message events. Session identifies user session specific messages. SNMP classifies SNMP specific events. SSL logs SSL specific events. SVC classifies any connect client messages. SYS logs system specific events. VM classifies VLAN mapping messages. VPDN classifies L2TP session messages. VPN classifies the IKE and IPsec related messages. VPNC identifies the VPN client specific events. VPNFO logs VPN failover messages. VPNLB logs VPN load balancing events. WebFo logs web VPN failover messages. WebVPN logs web VPN related messages. In figure 322, a logging list called IPsec critical is set up to group all VPN, IKE and IPsec messages. The selected severity level is critical, which also includes level 0 and level 1 events. Logging types. Cisco supports the following types of logging capabilities: external syslog server logging, external SNMP server logging, buffered logging, console logging. Console logging enables the security appliance to send syslog messages to the console serial port. This method is used for viewing specific live events during troubleshooting. Terminal logging. Terminal logging sends syslog messages to a remote terminal monitor such as a telnet or a SSH session. This method is also useful for viewing live events during troubleshooting. It is recommended that you define an event class for terminal loggings so that your session does not get overwhelmed with the logs. ASDM logging. You can also enable the security appliance to send logs to Cisco ASDM. This feature is extremely useful if you use ASDM as the configuration and monitoring platform. You can specify the number of messages that exist in the ASDM buffer. By default, ASDM shows 100 messages in the ASDM logging window. Email logging. The security appliance supports sending log messages directly to individual email addresses. This feature is extremely useful when you are interested in getting immediate notification when the security appliance generates a specific log message. When an interesting event occurs, the security appliance contacts the specified email server and sends an email message to the email recipient from a pre-configured email account. Syslog server logging. Cisco ASA supports sending the events log to one or multiple external syslog servers. Messages can be stored for use in anomaly detection or event correlation. The security appliance allows the use of both TCP and UDP protocols to communicate with a syslog server. You must define an external server to send the logs to it. Buffered logging. The security appliance allocates 96 bytes of memory to store log messages in its buffer. This is the preferred method to troubleshoot an issue because it does not overwhelm the console or the terminal ports. If you are troubleshooting an issue that needs to store more messages than it can store, increase the buffer size up to 16,384 bytes. In figure 323, the logging level for the syslog server is set up for debugging. The figure also illustrates that the logging level for SNMP trap is an event list called failover communication. Internal buffered logging is set to debug. Email logging is set to the failover communication event list. Telnet and SSH sessions logging is set to the IPsec critical event list. Sys logging is set to debug, and ASDM logging is set to the information level. The email and syslog server parameters are configured later in this chapter. So I can see here, figure 323, forwarding syslogs to multiple stores. Example 346 shows the equivalent configuration of figure 323. You can view the buffered logs by using the show logging command as demonstrated in example 347. This shows all different types of logging supported on the security appliance and indicates whether they are enabled or disabled. Additionally, it provides the number of messages logged on each of the configured logging types with the logging severity. Each syslog a message alerts with the %ASA to indicate that a Cisco security appliance generated the message, followed by the logging level, the unique message ID, and then a brief string to describe the log message, as you can see here. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.